People saying I'm late. I'm never late. I should probably put this away. It is 8 p.m. It is okay. It's 1 minute past 8 p.m. I'm 1 minute late. So yeah, I guess that's okay for YouTube standards. Yeah, hello everyone. YouTube live build of the Prusa i3 Mark II 3D printer clone. I did change the title because people were asking, hey, what are you building the entire time? So yeah, that should be taken care of. Yes, we've got 2 mods in chat. We've got slow mode in chat, so that's 1 message every 5 seconds, which is, I think, totally reasonable. Nightbot is here too. Guys, please keep it civil. I know this is the internet, but... Alright, got that out of the way. There were actually a few questions in chat that I did want to answer. So, someone was asking about the rod lengths for the Y-axis base that we built yesterday. That is all on the link in the video description. The only ones that I didn't list yet were the rod lengths for the M5 rod, because this one is going to be cut to length for the Z-axis. You see that over here? For the Z-axis spindles right here, so we're obviously not going to be using the integrated lead screw motors as the original one, but we're going to use couplers and the M5 threaded rod right there. So yeah, I'm just going to measure that out and cut that real quick when we get to that point. The other thing that was asked was, where do the end stops sit on the... Did I just bend this? No. Where do the end stops sit on the original ones? So let's check that out. So first of all, oh, I can use these cameras blindly now. That is, I've used these too much. First of all, so X-axis on the original Mark II has its end stop right down here. That little black nub right there, that is the end stop on the X-axis. That's just screwed onto the bottom. I'm hoping the part that let's shut you up. I'm hoping the part that I designed for this clone build is going to fit. It does, in theory, fit the modified or the other end stop. And of course, for the Z-axis, that is exactly the same as on the clone build right here. You can sort of see it poking through right there. That's the end stop for the Y-axis. So pretty much same positions for the clone build. So yeah, firmware-wise, we should be fairly compatible. Same size of the bed? No, slightly smaller, but the idea is that we are going to be able to upgrade this machine to the Mark 42 once it's built, and it's just going to get most of the Mark II or Mark IIs features once you add... No bloodshed today, let's hope for that. It's going to get most of the features of the Mark II once it's done and once those are available. Cool. Thread rod, zinc plated work. Yes, these are all galvanized, so those are going to work. Obviously, the galvanized layer is going to wear off over time, but it should be fine. It should be fine. So, yeah, I've got... What are you building? Those questions again. I've got my tea here. It's going to be just a very relaxed stream today. I know it. So, let's check out where we stopped. So that is YouTube Live control panel. What is it called? Live control room. Just in case you want to see how that looks. Let's see. So that's essentially where we left off yesterday. Cable management, we decided to skip that because I was like, whatever. We're gonna, do that once we're done. But yeah, the next thing we need to do is leveling the y-axis, and I'm just gonna retighten all these nuts to get it somewhat even and yeah, level. And let's do that right now. So I think I'm actually gonna switch over here and turn that on. Now, you need a ow. God damn it. You need a flat surface to do this. So they recommend using the original aluminum frame as a reference surface. I've got this work surface right here. You can see this is just particle board with a laminate on top, or a plastic laminate actually on top, and that is processed wood, so that is very flat by default. Also, the under construction here is pretty massive, so it is. I know it is flat. And the way Prusa recommends checking for flatness, actually squaring, we did that last time already. We measured diagonally across. So just from one corner to the next and check that it was the same on the other two corners, and that was exactly the same. Let's actually put this thing into airplane mode. There we go. So the diagonal dimensions were exactly the same. So yeah, that is how we squared the frame. Did I buy Google Ads? No, I've never purchased a Google ad. It's not AdSense, it's ad. Whatever, the other one. I've never purchased an ad through Google, and I don't see the need for it right now. It might have, yesterday's carriage might have just been, you know, streaming during a work day, reasonable people being at work, maybe kids being off school. Who knows? We'll probably never know, but today we shall be fine. Right, I'm just tightening up one side for now. We did align these in a prior step to get the y-axis to move smoothly, and it still does. So the way they're recommending to square these, let's switch over to that, is to actually put it down flat and then tap each corner to see if it's check the belt first. The belt is perfect. Then checking each corner whether it makes a noise when you press down on it or tap down on it. So this corner, pretty good, it's pretty solid. This one also solid because the motor obviously is resting on this side, so it's pulling this corner down. This one also good, but this one, obviously that is shaking. So that corner back here, we just need to twist this back, and this can be a bit of a fiddly task to do. You don't have to get this perfectly right. If you have some felt pads or something to put on the feet right there, you can just, you know, put them on there. They're going to take up some of the slack, so, you know, you don't need to get it perfect, but just for alignment reasons, it's still nice to have it as close to perfect as possible. This cost more than $100, right? Yes, it did. But, you know, the 3D printer under $100, a fully featured, complete one, is pretty much a pipe dream. Yes, you can get super cheap, stripped down ones that like don't have a heated bed or something, or are super reduced in features or size, but this is a fully featured 3D printer. Printer name, god damn it, just look in the video title. I swear. Yeah. That is the last time I'm gonna acknowledge one of the questions from chat like that. But yeah, this is a fully featured Prusa i3 Mark II clone build, so you are getting most of the features of like the big guy printers. You are getting a heated bed, you are getting auto leveling, you are getting decent motors, a somewhat decent hot end, and you're getting an upgrade path. That's the other thing you're getting. So if you want to improve some of the components here, you can do that. You can just swap in like in new frame parts, a new electronic set or something, and, you know, make it a better, different printer, whatever you want. Make it yours. That's one of the ideas of the DIY 3D printing idea and of the RepRap concept as well. So, language? Thankfully not, but isn't watching my live stream language, so it's joke's on you. You can also check by tapping each corner and listening if it's making any noise. So we did that, and now they are sitting pretty much perfectly flush, so that's okay. You can use aluminum frame. We didn't do that. Felt pads. We don't have any felt pads. I could stick some on there. I might do that after the build. Just, you know, putting some foam tape or something on there, just to give it a bit of like noise absorption on here. But the best way of reducing noise of a 3D printer is not by like absorbing it with like fluffy feet or something. It's by actually reducing it at the source, and that is just using better drivers for your stepper motors so that they don't create that much noise in the first place. So end stop, that is just checking the end stop, so we can do that real quick again. We already did it last time, and probably did it a bit too much last time, but I'm fine with that. I'm going to do that again. So we've got the end stop back here. That's the clicky part right there. Yeah, this is all merit for me. And essentially the part that it crashes into is this belt holder on the bottom. And let's turn myself off. There we go. And you might be able to see that. Yeah. And it's making a nice click noise, so it is contacting well. Right, how come in the video I introduced this, I already had it built? It should be pretty obvious. Have I heard about the hang printer? Yeah, I've seen your messages about that in chat just a minute ago. I'm gonna see it in Sweden at the 3D printing meetup in Sweden, which is gonna be a pretty nice event, I think. Congratulations, you have assembled the y-axis. You can continue by assembling the x-axis in the next chapter. So let's move this thing out of the way and get to the x-axis. So the cool thing about the build here is that you're like not, well, I guess it's cool on one side, but it's also, it hides a lot of the progress you're making. You're not building like the frame first and then adding components onto it. We've still got, I mean, we've still got like the original, yeah, the original Prusa frame just by itself. We used it a few times to align the bottom, but we've not installed it yet. So you are getting individual components, and then in the end you put them all together and you get a printer that just goes plop, 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 and all of a sudden you have a hopefully working 3D printer. Right, so tools, yeah, we got those. We need the X carriage, the X end motor, and the X end idler. So let's grab those. This guy, and that guy. And 3 bearings, LMATU. 1, 2, 3. And the longest one, so these are the 370mm smooth rods. We're gonna grab those as well. Carefully slide linear bearings on rods. I can do that. How many pages in Chrome? Not enough. So obviously when you do slide these on here, you do want to be careful not to introduce any dust or grime or other crap to the system, to these bearings, because I mean that they have the rubber gaskets on their end. They aren't, come on camera, these gaskets on the end here, these aren't super tight or super sealed. I mean they are sealed in the end, but you should try to like not get any dirt or grime in there in the first place. So at least you should be able to get a fresh start there. Donations, tips. Oh, you're already overstressing me. But of course, I don't want to leave anyone out, so let's do that. In a second when the page loads up. So A link to the Prusa i3 Mark II manual. So the original printed manual that Prusa shipped with the machines, I've not found that online yet. There we go. And people keep saying, yeah, just turn off chat. Yeah, sure. Great idea. So while that loads over here, let's actually get this T out. I sort of, I sort of like this holder. It's not paid product placement. I don't even know what this thing is called. It's a pretty cool tea egg. All right, let me check stream tip here. Come on. Do I have? Okay, one second, please. Sound? Mic's muted? Mic is not muted. Well, no, it's not. I can... Hold on, that was... I scrolled up here. Audio is fine now. Let's print, yeah. Have I measured the rods? Most of them are smaller than 8 millimeters and are something like 7.64 millimeters. Actually, I've not measured them, but I am relying on the seat between the bearing and the rod just being smooth enough. So, I mean, obviously these are working fine. These are making the proper LM8U noise. So once they run in, they're like, they're gonna run perfectly. This one is okay. This one is maybe a bit tight, even over here. So I don't know. I don't think I'm actually going to use this one again. That's the recommendation right there. Just buy a spare pair because these don't come with the greatest tolerances. So if you actually get one that is too tight, just grab another one. Wait, too tight or too loose. Just grab another one and use that instead. Let's just do that right there. So stream tips. Today. There we go. Antonio Riviera. Thanks for the €5. Mongo Ellen. Thanks for the 3 years. 20 years from Hendrik Johns and $100 from a guy with an unpronounceable name. But thank you for that. And Naked Ape TV on YouTube Super Chat as well. 10 Canadian dollars. Thank you for that. Obviously, more content all week. What meetup in Sweden? Check Google 3dmeetup.se, I think it is, or something. And 10 years from Rudolph. Rudolph, sorry. So sorry that I'm laughing, but yeah, thanks for the tip. You cannot paste the link in chat. Yes, too bad. I know, but mod rules. Let's get back to assembling, because that's what we're here for. Insert LM8U. So we did that. We stream tip. Let's get this thing back on full screen. Sorry, a few too many windows right now. Like that. That's fine. So essentially, bearings over here, and let's get back now back and sweep. Excuse the interruption there. Right, so we got the LM8U bearings on the shafts for the x-axis and the printed parts for the x-ends, so that are these two. Also get their bearings. Again, that's something that I mentioned in the stream yesterday. This thing did warp a bit. So when you're printing with ABS, sometimes parts are just gonna warp. There's not a whole lot you can do about it. Well, you can do a whole lot about it, but sometimes it's just, yeah, it just doesn't matter. Like this one here, this one is a bit bowed on the top surface. That's okay. This nut, this Z-axis nut, isn't going to seat perfectly, but it's going to be fine. It's going to be pretty okay. Most of these parts are, again, made to take up some slack, to take up some tolerances, and yeah, that's exactly what we're relying on here. So again, deburring tool, that's what these things are called. Awesome tools. They're like a $1.50 or something. I did link that under yesterday's video or yesterday's stream. These are pretty awesome for just taking the burr and the lip off of these 3D printed parts. Will I be bringing a 3D printer to the meetup? Probably not. The thing is, I'm going to be at CeBIT in Hanover before that. 2 days before that, and I'm gonna go straight from there to the 3D meetup. So it's gonna be a lot of traveling, and I sort of don't want to lug a 3D printer around. If anything, it would be like the Fabricator Mini, like that guy, the orange guy back there. But that's not a particularly great machine to bring to a meetup and to show off. So I don't know. Nightbot? You there? Yeah, large print. So one of the... Interesting, Nightbot's not catching that. One of the tricks that I've started doing with... can you see it on... Yeah, you can see it on this one. Which actually it didn't work out on this print, but... one of the things I usually like to do is to just print a really fat first layer. So over here. So this one actually warped, which is, I know it's kind of ironic. This one also slightly warped. But what I like to do, especially if you have a bed that is just slightly uneven, just increase that width, that first layer extrusion width, and also layer height. I don't think you can see it that well, but that is just going to take up any tolerances in the in your bed alignment and just give you a much more consistent layer like there. Is there a source for the 3D printed parts? So actually these printed parts, if you don't have a 3D printer, and that's actually one of the questions that's coming up quite a lot. I could produce them, I could print them and sell them. The problem there being my business model, my officially registered business model sort of doesn't allow me to trade physical goods and to actually sell physical goods. Come on. So I'm not sure if I'm like legally allowed to sell these. But you can check on, there we go, that's in. You can check on pages like 3D Hubs. They're usually not the cheapest, but there are some 3D printer owners that will sell you 3D printed parts for a fairly low rate. And to be honest, they are actually sometimes cheaper than just buying the full kits on eBay, just getting them custom made on 3D Hubs. So that's something to definitely look into. Yeah, printer parts, check eBay. Yeah, the thing with eBay is, again, that is just a standard set of parts that you're going to get, and it's mostly going to be like old i3 parts from 2012 or something. Can someone sell them under Creative Commons? Yes, they are. Creative Commons share alike or something, attribution share alike, I don't know. Plus copyright on physical parts is a tough topic anyway, since it doesn't really apply, unfortunately. Perk on Patreon? Ooh, that's a good idea. You don't require registration to do business. Yeah. Germany. Okay, I'm actually gonna... Well, I'm just gonna press fit these, or this one in the vise, because that's not going in, at least it's not going in straight by hand. So I'll be right back. I've got the screen for that. I'm just gonna press fit that real quickly. Double check, whatever. I don't know if audio is still on, but I'll just pretend it is. So. Actually, I could bring the mice over there. That'd be a good idea. But for now, let's just press this guy in, because these printed parts are pretty tight, which is good. That's actually shaving up parts of the plastic. That's cool. But they are a bit too tight for me to just insert in hand, and I do want to get these things finished. Right, got these bearings pressed in. It was just a bit too... Rip headphones? Sorry. It was just a bit too tight for me to insert by hand, at least to insert straight. So let's double check these. So there is a bit of swarf in here with the bearing just being pressed in. So these are clear now. I'm losing my balls. So what we're seeing right now is that these parts are just a bit too tight or a bit misaligned due to the part warping down here. So yeah, we're not getting the rod in as far as we need to. So obviously if we had parts that were a bit less loose, and this one is actually losing its balls, which I'm not going to mind too much right now. Yeah, you can sort of press it in, but it's going to be very badly misaligned. So what we can do is just to grab a hot air gun and heat up the entire part a bit to get it aligned. And this is something that you should do, you know, carefully, obviously. What's the other one? Ha! This is something that you should do carefully to just, you know, soften up the entire part as one piece and not melt a single part. Is it bad when the balls come out of the bearings? Yes, it is, because then they're not going to be recirculating as nicely again, or as nicely anymore. So avoid that if you can. Yeah, that's also, Daniel is saying he requested at a company, A3D. Yeah, so, ow. So that's properly hot. So one of the options, of course, being 3D hubs, the other options being like 3D printing meetups, meeting people, you know, getting in touch with them. That's also a great option to just start with the entire 3D printing endeavor. Or, you know, visiting a makerspace, Fab Lab, learning the ins and outs of 3D printers before you get into building your own, and then once you're confident you're going to be able to make good use of one and are going to be able to use one yourself without help, then you can make that leap and actually buy your own and build your own. Let's see if this any better. No, it is not. Is it the bearing or is it... No, it's not the bearing because it's fine this way. Let's see which way we are misaligned here. It looks like we need a bit of a twist this way. So the other thing I could do is just to ream the entire bore right here. This is slightly flexible, so this part does have that built-in spring right there because it is open on the one side. This does flex, so if you have a, what are these? 8, so these are 14 millimeters-ish, 16. You could just go ahead and get this thing bored out and it should align a bit better, and I can actually see this guy being ever so slightly misaligned. Let's try and fix this. Does it hurt to add a bit of oil to the bearings? Not at all. How's the ANET A8? Everyone's still asking about the ANET A8, and it's still the same answer from me. I will have an opinion once GearBest actually managed to deliver one to me, because they have promised one probably now half a year ago. So, and I've still not gotten it. So, yeah, not gonna comment on a machine that I don't have. At least I'll try not to. So that's not working. Instead, I don't have a hammer. I should just grab a hammer. Instead, what I'm gonna do is just hammer this bearing in a bit further. This might be a bad idea. Should I use a chisel? Probably not. Yeah, so down here, this is just really tight. And that's the part where it warped. So now these are backed up against each other, and ooh, I can get it in, but it's pretty rough. Oh, let's see. This is going to be the Z-axis. Let's not worry about it too much for now. We can always come back and replace this part. That's the good part. It's gonna, it's gonna work well enough. I could remove both bearings, yeah, and reinsert them as a unit, but still. This one, obviously, the motor end is fine. Yeah, and this one now that's sort of running in, doing well. Do you recommend any upgrades for the actual original Mark II kit? I've been using mine without any upgrades. Oh, is that true? Yeah, I put a hardened nozzle in one, but for the most part, don't see the need for it. Cool. So we got the bearings in. They run reasonably well. They're not perfect, but anyways, thank you for the tips from Matthew and what was that? David saying thanks for the guides, very helpful. Sweet. Hit it with a shaft in. Yeah, I forgot to align the bearings. Let's see. You can press the flat surface for easier insertion. Yes. Pairing tension screws. So the official statement from the official statement from Prusa is like these tension screws right here, they're like leftovers from early designs, but they're still putting them in. I think they're still a good idea. I think they still give the x-axis something to work against the forces from the belt, because once you put these rods in, hoping this is the right way around, no, like this. Once you put the rods in here, you are going to have a belt pulling these two parts together essentially, and you know that by default the rod can just slide. I'm actually holding this back, so this way. You're actually going to have the bars slide loosely in actually the idler end, this end, and if you have these screws in this end, it's just going to keep that from happening, and you can essentially tension the entire axis. You can essentially push these two parts apart from each other with those screws in the end. red ball from bearing next to the belt on your desk. No, not at all. Cool. Yeah, let's do that. So square nuts. One thing I actually realized before starting the stream today, I bought like this set of fasteners. They're over here, they're just off frame. But I bought all these fasteners plus the, actually that there they are, all these fasteners plus the threaded rods, and I got everything twice. So I got 2 packs of everything I ordered. So I now have like 2 packs of washers, cap head screws, nuts. I've got everything. I got the double amount of everything that I ordered. Not that I'd mind. It's just weird. It came in 2 packets. And I guess what happened was just that, you know, they put all the small parts in each packet. So I got everything twice. Again, I don't mind. So square nuts and M3 times 10 screws. So that's these over here. Ripstream? What? Nah, stream's fine. So these actually go in here from the bottom. Okay, from the bottom and the top. So got these slots, and if you ever design something for 3D printing, that is a great design element, just having those square slots for square nuts. The hex nuts, the hex nuts are usually you know, much easier to just get loose and twist in the holes there, but these just drop right in, and you know, you can just screw them in from the other side right here, and that's going to catch on the square nut in there. Upgrade bearings on the MK2S. Yeah, that's one of the big things. I think smooth rods as well, but I don't want to spread any false info there. These parts are ABS. All of them, that's why they warped slightly. I wouldn't recommend PLA for 3D printed parts, just for durability reasons. It looks like the 10mm screw is actually slightly too short, but it is actually too... Oh, okay, it does have the counterbore there, so it's going to sink in right there. Like, PayPal doesn't work on Prusa. Oh, you might want to write them an email about that. They were having an issue with like PayPal payouts. They did have over $1 million stuck in the PayPal account, and they were like, guys, we sort of need to buy parts. Please, like, PayPal, please send some money over. So that might be just an extension of that issue with PayPal right there. Thanks for the tip from Florian. Qualität deiner Videos ist 1A. Yeah, well, videos, edited videos. That's something not a lot of people understand. Is, you know, live streams are live. Live streams are just a more casual way of answering your questions, of reading chat, and that's one of the main reasons why I'm keeping chat, no matter how vile it gets. But yeah, live streams are live. Live streams are just something that are different from an edited and scripted video. They are going to be raw. They are going to be unedited. That's the fun of them. And if something goes wrong, then it goes wrong. That's just the point of it. That's one of the reasons why I do unboxings live. Okay, insert the rods with the bearings fully into the printed parts. Ensure the correct orientation of the parts and rods. Rods with 2 bearings must be on the side with the nut trap. Very carefully, do not tilt the rods, that is, bend the rods too much. Let's do that. So we're not going to be using the idler just yet. Actually, let's do this on this one. Nut traps are on top right there. So 2 bearings on top like this, and you've probably seen the face on the X carriage of the Mark IIs. This might have been on purpose. This might have been accidental, but I like it nonetheless. So let's see if we can actually fit this guy in here. It doesn't look like it, and ABS does like to crack its layers, so yeah, I am not going to force that in. I am going to grab a I'm gonna grab a, oh, I don't want to blow more earphones. So I'm gonna grab a drill bit and just ream that out to 8mm so that we can get it fitting perfectly. Workshop. Over here, by the way, is where I used to shoot all my videos. So if you're looking through the older ones, this is the studio, or used to be the studio, which is now a workshop only room. Which makes sense because camera equipment and 3D printers doesn't really mix too well with grinder dust and stuff like that. Why have I not packed the bearings with grease? I do recommend that, right? Can you trust a seller on AliExpress? I do not know. Depends. AliExpress isn't just one seller. AliExpress is a bunch of sellers. It's more like eBay than on Amazon. So, you know, one seller might be great, another might be not so great to work with. Hypercube from Tech2C, haven't looked into that one. So again, don't have an opinion on it. Why ABS and not PETG? I don't know. Sometimes I like to do dumb things. Yeah, PETG obviously also an option, but like for the hot end parts, the parts that are close to heat sources, I probably wouldn't be too comfortable just going with PETG only. How to print the parts? Should be somewhat self-explanatory, but might be worth making a video about. There we go. Let's align it. That's gonna slide right on. For the most part, while I'm reading chat. Has Prusa said anything about the clone yet? He was actually here yesterday. He joined in. Oh, you know what? I forgot. I got more lights. He was here yesterday, and you know he's a rep guy. Still is, I believe. So I mean, he's making his designs open source for a reason. And one of the reasons being, you know, you can build your own. You can mod your own. So yeah, is ABS still relevant? For stuff like this, it is somewhat relevant still. When you need that extreme heat resistance, PLA just doesn't have any sort of heat resistance at all. And for 3D printer parts, it's not a great choice. What ABS? Rigid ink. Set the rods very carefully. Preparing the X and idler M3 by 18 screws. Got 2 packs of M3 by 20s. So obviously, when you get the screws in these little baggies, that is one of the best things you can do. Just keep them in there, or you know, if you want to go really fancy, you can get an assortment box and just throw them in there. But like these baggies are pretty good to have. M3 times 18s, we're gonna need a idler bearing. That's over here. Again, that's the aluminum part with embedded bearings. Nylock nuts, 1. That's the open bag over here. And that's that. So let's see. So the idler on this one is over here. We've got the nut trap on this side. This should fit the lock nut. And then, wait, 2, 1. 1 screw over here. And this one goes in here. Should we put washers in there? It doesn't look like it. Okay. So right there, there's the hole for inserting the idler. And without a washer even on any side, or is there a stand-up integrated into the part? This is, okay, it's open on both sides. Fiddling in parts like that is always sort of tricky, but it helps to just use some tweezers, obviously, which I have over here, and align them real well to the hole. Just pop the screw in and keep it in place. No washers. Works on the original one. For people asking, hey, which printer have you printed these parts on? Obviously on the Mark II, on the original one, because that's my go-to printer, and that's my printer in a box for ABS and the likes. Cool, that's smooth. So x-axis done. Right. Okay, secured in position using the screws. We did that. Tighten but the idler must rotate freely. We've got that. So next up, zip ties. Insert zip ties as shown. So these all go in from the top. So zip tie closing piece right there from the top. Let's do that. And a bunch of zip ties. How did I modify them? So yeah, this X-end idler right here, this is one of the modified parts. Obviously this flange right there with the end stop mounting holes isn't part of the original one. Also the other end stop mounting part, that is all modified, and I essentially just modified the STL itself. Modifying the STL itself, without any tools is super tricky, because you're getting a 3D triangle based model. You don't get any shapes, you don't get any features like it would have in a real CAD tool. But what I did instead was to model these parts in a CAD tool onto an imported STL, and then merged the modified part and the original one in Mesh Mixer, which is a pain. It's a total mess to do. Ideally, you would modify these parts in the same program you use to create them. So these parts are all done in OpenSCAD. So ideally, you would want to learn OpenSCAD and modify it right in there. But I don't do OpenSCAD. I don't know how to use it. So yeah. Yeah, STL is applesauce. That is actually a pretty good comparison. So next up, I believe we are going to place the X carriage onto the X-axis base as shown in the picture. Obviously, there is a cutout for one bearing and a cutout for two, and those just need to be aligned. Use pliers to tighten the zip ties. We can do that. So that goes on here. Up here. Obviously, these zip ties that I'm using here are a bit too long. These are 150 millimeters, so 6-inch ones. You could go with the 100 millimeter ones, and that should be a bit easier and a bit less messy. Like these are going to work just fine as well. And now it's just a matter of tightening all of these up. Put the zip ties upside down, whatever. I don't... Yeah, some of them. It's not gonna matter. Just to be completely honest with you guys here. The manual says, yeah, make sure you orient them correctly. Whatever. I've done worse things in 3D printer assemblies. But you guys have a keen eye. Respect for that. I mean, we can always slide these around and put them in the right spots. Why is OpenSCAD so popular for 3D printing? I do have a theory there. 3D printing is a nerd sport. Oh, quality zip ties. Cool. 3D printing is a nerd sport. Or used to be, at least. And, you know, nerds, typically programmers. And OpenSCAD is essentially that. It is 3D programming. And, you know, I've heard from a lot of people that just like the mindset of OpenSCAD, where you just have everything parametric. You have a few input variables that you just define at the very front. You've got that very clean, very strict setup of a 3D printed part. And I guess it just flows very well with the same idea as programming code. It is programming code. It is that exact same thing. So yeah, I guess it's just the same approach to creating a 3D model that it is to creating a 3D model. And yeah, it was pretty much like the only powerful enough tool to create 3D models back in the day, back in the old days. So yeah, this zip tie over here that I already tore off. This isn't super tight, but well, I guess it's good enough. This one also isn't super tight. So zip ties, nylon zip ties, they might stretch over time. They might actually, you know, loosen up and just make your bearing mounts a bit wobbly over time. And, you know, that's just something to check for every now and then. And, you know, if they actually have loosened up too much, you can retighten them. Obviously not this one that just tore off the entire overhanging part. Or replace them. It's just something that you have to keep in mind when you are using zip ties. That's one of the things. If you've got screwed down parts, even the plastic itself might start creeping and you know, loosen up over time. So yeah. Have I tried Blender? Have I tried cocaine? Yes, I've tried Blender, but it's not something I really want to get into. Hold on. Whew, I did it the right way around. Yay me. I was having a bit of a shock there, because you can put this part on this way or the other way around, so okay. This is the right way around. That would have been embarrassing. Right, tighten the X carriage. We did that. We tightened this up well enough. Cleaning up. Cut that off, did that. Next motor. So M 3x18 and the motor. Got it. So motors again, we're using just the standard type with the plugs in the end. Blender is like GIMP. Nah, I don't know. I actually like the GIMP. I like it a lot. It's a great tool. It's like, you know, it's really close to Photoshop. In some extents, it's even a bit more powerful than Photoshop. But you know, if you've got Photoshop, thank you for that. If you've got Photoshop, there is no reason to use the GIMP. And it's different with Blender versus whatever else you want to compare it with, because there is, well, what would it be? You can't really compare Blender to Fusion 360 or other CAD tools. What? Oh, this way. You can't really compare it to Fusion 360 or other CAD tools because it's not that. Blender is an artist's tool. Blender is a 3D, what's it called? A 3D graphics modeler? 3D graphics? Yeah. It's a tool you use to create 3D art for the most part. It's not a great tool for creating 3D CAD mechanical designs. And that's just the difference. Blender itself is an awesome, powerful tool. Again, there is a bit of a barrier when it comes to just learning the ins and outs of how it works and how the general approach to the software is. But it's a different tool. It's a tool for different needs than what the classic CAD tools are. Blend and Maya. That's tight. 3ds Max. Yeah, is that the Blender equivalent? I think so. The commercial one. Maya's for animation. The ZBrush yet again is a totally different approach. So that is, you know, again, even more leaning towards the art approach than Blender, something like that. Assemble the X motor pulley. We can do that. So again, this guy has the opening over here. You can see all the way, if I can align it, yeah, you can see through to the carriage. Of course, now it's bouncing around like crazy, but the belt is actually going to go through this hole back here. And actually, let me check right now. So someone was commenting, hey, why are you recommending 16-tooth pulleys when the original one is actually using 20-tooth? And I'm pretty sure these are 16-tooth. Oh, that's going to be sketchy. Okay, don't turn that wheel. So that's the original one on the shaft right there. And this is the 16-tooth. That's looking pretty close. That's looking pretty much like the same size. And I do have a 20-tooth one somewhere. Yeah, that's an awesome location. Somewhere in the world there is a 20-tooth pulley. That's an 8mm one, okay. This is 2. Where's the stuff when you need it? There we go. That's the 20. So that is the 16-tooth one right there, and this is the... thinking that's a 20, but that is a lot larger than the one that's on there. So 16-tooth it is. Thinking this is 20. Pretty sure it is. But yeah, original ones are 16-tooth confirmed. There you go. Functional precise parts. Yeah, Kevin has it pretty much down to what the different CAD tools are all about. Now, CAD licensing is sort of tricky because a lot of them, especially like the Autodesk tools, are like, yeah, it's free, but you know, if you're using them for business, for startup stuff, it's free if you're making under 100K revenue, and like if you're a hobbyist, yeah, you can also get it, but like don't make products with it. It's very, yeah, it's that's one of the license models that I don't like. I can't really adapt to that. So that's one of the reasons why I like Onshape, like very down to earth, just going, yeah, okay. You know, you can use everything for free. If you want like advanced stuff like rendering and simulation, that sort of stuff, you can buy cloud credits and like not have to simulate it on your own machine. But like there is that limit. You have to publish everything. Every model you make is going to be automatically public. I'm fine with that. I'm not making a living off of my CAD models, and I do usually release them under a very liberal license. But of course, for others, that might be a larger stopgap than saying, okay, if you're making under 100K revenue, which I imagine for a startup is, I don't know, which real company is making less than 100K revenue. I have a hard time imagining one. Like, you have one employee, you're making more than 100K revenue, hopefully. So yeah, that's like a very superficial license promise from the Fusions 360 guys there. So yeah, now it doesn't depend on making more than 100K with the tool. It's just about making more than 100K as a business total. So yeah, it doesn't just limit that that revenue limit to the work you do with Fusions 360. Just the position, we did that. Thank you for the tip, JF. Let's see. In axis with the cutout. Got it. Tighten up the pulley. Yeah, Loctite on those would be nice. Ah, okay. So next up would be the end stop. So of course, this part we're just gonna skip complete. Well, we're not gonna skip. We're gonna replace it with with the MakerBot style end stops on a PCB. Julian Fernandez Barcelona is asking what do I think about the BQ Witbox. There is a review video of the BQ Witbox on my channel. Obviously, many of you will know my history with BQ, so I try not to comment on them too much because I don't think I can give a neutral comment on this situation. So, yeah. If you want to look that up, you can. Feel free to do so. So this end stop right here, this one should, well, this one obviously fits on these two nubs right there. That angle is crap for that, but I'm thinking this was meant to be forward facing. Let's see. So this is obviously sliding past completely. But there are gonna more parts sitting on here, and I did check in the CAD model. Nope, this way. So if we put this on like this, that this switch would actually trigger against something. And let's just see what that's gonna look like. That is the main body with the filament feed hole towards the two bearings. Grab that. That's this part, filament feed hole towards two bearings, so that is lined up like this. And then we're gonna have the fan. Yeah, okay, so hot end fan is gonna sit right here, and that's what this is gonna trigger against. I think I saw a trigger against a screw in the CAD, but it's just gonna trigger against the hot end fan body, which is okay. That's always gonna be there. Done, did it. Does the Mark II print as good as a good Core XY? I have no idea what it is with you guys in Core XY setups. It's literally just another belt setup. There's nothing special or unique or, you know, superior about a Core XY versus a Cartesian machine. It's just another way of making things move. So, you know, a Core XY isn't like that magic bullet that you use and all of a sudden, you know, you get great prints. Oh, Core XY, of course, it's the best thing ever. It's not. You can build a completely useless Core XY printer. You can build a completely useless Prusa i3 style machine. You can build a completely useless Delta. It's not about the kinematics platform. It's about how you build it. 3 times 6. Looking good. So yeah, I don't get it. Yeah, why did I choose these? Because these are literally the cheapest ones you can get. I did mod the parts to fit them, but these are with the cable, which is great. These are literally 30 cents per piece. So you can get a full sets of mechanical end stops for $1, which is pretty unbeatable in my book. Could a Core XY have less vibrations? Well, you can build a regular Cartesian machine without the bed moving. Just look at the Ultimaker. That popped off. Or the BCN Sigma. In fact, BCN Sigma does not have a moving bed either. Well, it's gonna, of course, along the Z-axis, you sort of need to have that, but it's not about the Core XY. It is completely irrelevant. This is fitting pretty well. I'm just hoping it's gonna seat against something and trigger against something. It has the benefit of a light hot end. Yeah, the Core XY. There isn't just one Core XY design, guys. There are a ton. Cool. So the end stop is on there nicely. This is fitting really nicely. Let's see. Who messed with my cameras? I know a guy who has. There we go. So this is fitting on there really nicely. I didn't expect this. Obviously, this is first try for me. These were only tested in CAD. These were not assembled before. And this is just fitting really well. The relief cuts on the bottom are working out well, and it looks like it's going to have something triggering it. So cool. People use Core XY interchangeably with HBOT or other things. Good point. Good point. This versus Up Mini. Not used an Up Mini, can't comment on it. So obviously we did skip this part. And yeah, so the original one has this, can you see it on this overhead camera? Yeah, this nub down here. I thought about removing it, but that would have meant also putting up like a custom version of the X carriage, and I wanted to keep the custom versions to a minimum, so I just left the original nub in place here, which is fine. It's not getting in anyone's way. But yeah, if you want to do, you can always like reprint the accent and use the original one, use the original end stop, and just use that nub to trigger them. So, but yeah, that is looking fantastic. Make sure you hear a click. Well, we're not going to hear that click for a while. Cable management, that is also something for later. Use the small spiral wrap. Yeah, like I said, we're going to do the wire wrap when we're done with everything else. Thanks for the tip, Jan. Jan Camille. And I might have missed that one from John Hutchinson. Hope I pronounced that right. Impressed that you can build and talk at the same time. I can't. It's like this is pretty stressful for me. Like building, talking, keeping an eye on chat, managing video stuff. It's pretty stressful. It's work. It's, I mean, not the hardest work in the world, or not the yeah, no, it's something I enjoy doing, but it is work. So Z-axis, top left, top right, bottom right. Screw covers, we don't have these because we don't have the integrated lead screw stepper motors. Use the hole for 8mm smooth rod as orientation key in the next step. Oh, okay. Oh, we're doing the frame. So these screw lengths, did they mention them already? M3 times 10. So these were replaced by longer ones. So the BOM I published does include screws for that exact case. Right now, what this axis what this frame is, it's holes for the M3 screws so that you can screw them directly into the wood. That's not the most well robust way of attaching metric thread to a wooden part. So the way you can do is the way you can work around that is you can make a through hole through these parts with like a 3.2mm bore or something, and you know, put one of the large washers, which I have somewhere. One of these bags is the large washers. Put a large washer on the back, put another in there, and yeah. If these threads strip, I am gonna try to use screws directly into the frame. If you build this thing with a wooden frame, I would advise just to be safe to drill these with a 3.2mm drill or 1/8 inch. That's gonna work as well. I don't know. Do you guys use drills with inch size, or is it just number X drill? I don't know. Don't use US tools, but yeah, that's the option I would recommend just to be safe. Cool. Z motor mounts and the Z, what are these called? Top, Z-axis top, okay. Top left and right. So the blue marked one, that is right, and obviously right is when looking at the printer from the front. Yeah, I guess we can just take a peek at the original one here. The one thing we gotta keep in mind is that the smooth rods right here are on the outside. So if you look at these, we've got the threaded rod or the spindle in the, you know, towards the middle of the printer, and then the smooth rods on the outside. That's basically all we need to know for now. Which was it? Smooth rod on the, and that's the larger hole for the smooth rod. Okay, just like this. That's like that. And again, that is one of the reasons why the why these holes in the frame need to be somewhat precise, at least. So this wood is 18mm. The printed parts have a bit of material there, so we're going to use the 20 screws for now, 20mm long. Numbered or letter? Okay. Number bits. What machinists use number bits? Everyone else uses mostly inch fractions. I would have thought it would have been the other way around. But yeah, sometimes things are weird. Do I actually have a... Do I have a cutoff? Is that a 2? That's a 2 probably. So the problem is I did break or wear out my 2.5mm hex bit for the cordless drill, which, well, I guess I can try it, but it does eat into the screw heads and it's not a very pleasing experience. So I was gonna just take the take some big cutters and cut a hex wrench in half, but we can do it like that. Thank you for the tip, John. Yeah, that works beautifully. Let's actually put the torque limiter on here. That is actually set perfectly. Sweet. Everybody uses rulers in the US. Yeah. Okay. Let's... 3. Okay. 3 works well. Greetings back to Austria, dear neighbors. What do you think of wood filament? Lucas is asking. It's nice. I did do a Halloween episode on the 3D Prima wood filament, which is, you know, it has a great aesthetic. It smells great. It feels good. Wood screws, no. It feels great. It's a nice material to work with, but it is very clearly a decorative filament. It is not a filament you can use for mechanically functional parts. Maybe if you were like into speaker building, DIY speaker stuff, which I can understand. I do like that sort of stuff too. You could use it for like flares if you're embedding it into MDF speakers or other stuff where you just want to keep the wood theme. But I would not advise using wood filament for anything that has to hold anything or any sort of a mechanical load. It's just not a structural filament. And the thing is, the particles in there, they're not like carbon fiber particles that actually work well with the material, that they feel like they're working against the material. But again, that can depend heavily on the manufacturer and the exact material used. There we go. So this is not perfectly... Okay. Perfectly tight. Now it is. Now it is. Obviously, the original one has the smooth rods in there already. This one is better because this one has 3 screws in here, so yeah. Where in Germany am I based? Bavaria. Sweet, sweet Bavaria. Right. Tolman Bridge still off the heap. Still top of the heap in filament strength. Halloween.com actually has the ratings sortable and searchable, sort of. So that is something you can look up. Let's see. We should have deburred these first. Let's see if I can get it in here. Oh, yes, I can. So these holes back here are the ones that are going to fit the smooth rods over here. These are just going to slide in. Same up top here, actually. Let's just give this one a quick swipe. I think the Z rods might be slightly too long / short. I'm hoping they're going to be too long. These are, that's the wrong hole. I bet you don't want to hear me say that again. These might be a bit too short or too long, so these might stick out the top a tiny bit, but really it doesn't matter. So we've only got 1 pair left. That's these. Yeah, these actually lengthwise they're pretty good. They are pretty good. Am I going to add the bullet tools in the Halloween series? The bullet tests. Probably not, because it's not as scientific of a test as the rest of the tests were. So yeah, I didn't need to install the tops yet. Cool, but we know they fit. Awesome. Yeah, let's just double check that. So I did install the tops because like the manuals, they're hard to follow. So they show you the parts, they show you like, yeah, this is how they fit on, but then you mount the motor. Okay, but these are easy to take out, so no worries there. Yes, better parts, upgraded, etc. That is going to be a video once this one is built, once this one is working. For now, the focus is just building this cheapo printer, and everything cheaper or more expensive is going to come after that. Okay, so this is the custom part. This is where the custom part is going to start. So we do have the motor mounts on there. Those are going to fit us. But we obviously don't have the motors with the lead screws. You could use those too. And I think like standard nuts should fit on the parts as well. But those are sort of expensive. They are most definitely more expensive than just buying a motor and a threaded rod plus a coupler. So I'm not using those, and that is just custom work for the Z motors. So let's actually skip out of that and do motors plus couplers plus threaded rods. And I will need to cut those two sides in a second. Here's motor. I'm missing one. Oh well. Over here. Chat box a bit smaller. I don't think you'll be able to read anything there. Manually move the Z-axis, you knock everything out of alignment. Actually, no, that's one of the things. It's probably something that Prusa should improve too, but on the Mark II and on this one, the Z-axis might be a bit too steep, the pitch of the Z-axis. But the cool thing with the Mark II, with the original Mark II, is that you don't need to do that. What it does is essentially runs the... Actually, you can push these around by hand. These Z-axis spindles are so steep. These are 4-star, so they have an 8mm pitch. I can just, push the Z-axis around by hand. Totally no problem. But when you run the calibration loop, and I've actually set up my start G-code in the same way, all they do is they run the Z-axis all the way to the top, like that, and then the screws from the Z-axis nuts, can we see these on here? Yeah, sort of. The screws from the Z-axis nuts just ram into, well, it's the other way around. It's the screws on the Z top parts run into the X ends, and the motor skips and everything's fine. Everything perfectly aligns every time. And I'm not sure, again, if we're going to be able to use the same idea on this machine, because this axis is going to have a much higher linear force, because we're using M5 with a much shallower pitch. But we'll have to see. This one is not going to go out of alignment as easily as the original one, again with the much higher pitch. These are self-stemmed, self-locking more or less, trapezoid spindles, so these you will not be able to push around by hand. Push slightly above the limit, what? Yeah. But that's just the theory with that. So... Now when installing these Better. So when installing this sort of, let's actually use this motor for demonstration. When installing this sort of a flex coupler, there are a few things you want to avoid when installing it. Some of them are, a topic of discussion, as in there are different opinions on it. But here's the way I like to do it. So ideally, you obviously want the motor shaft to only engage with this half of the coupler. There's the flexi part in here, and then there's the other solid part on the end. So when only that side is engaged, it can essentially flex around freely. Now, the thing I like to do, which isn't really kosher in the way of, engineering ideas behind this coupler, is actually have the motor shaft go to pretty much halfway up the flex part. This is, this has a relatively good fit on here, but what I want to achieve, let me just show you real quick. Just lock this guy in here. I should grab a real hex key for this, if I had one. 3D lag dropped. So this shaft is going to about this position right here, and then as I grab the unnecessarily long M5, what? Oh, I didn't tighten it down. Cool. As I grab the M5 rod, okay, these couplers are just horribly machined. As I grab the M5 rod, this is going to back up all the way against the motor shaft, and as I tighten that down, I'm actually going to extend or stretch the coupler slightly, and then tighten that guy down. So the idea there is that this is going to be pre-tensioned, and the end of this thread rod is just going to seat up against the motor shaft. And when you push in this direction, this way, which you cannot see, when you push into the motor, this thing is not going to flex. There's not going to be any flex. So the z-axis by gravity is just going to sit firmly on the motor shaft. If you leave it with like a bit of wiggle room in here, that might show in your prints. So yeah, the other thing that Chad is bringing up, which is a great point, is using plastic tubing. You can use plastic tubing, totally. Chat, let me know. Should we use plastic tubing? Should we go for the all-out cheapo Prusa, which I originally announced? I do like the plastic tubing idea, but I mean, these are just the easy way out. I am using flexible coupling as a rigid one. No, I am not, because the flexible ones can still tilt. So when they sit flush up against the motor shaft, what they can do nonetheless is, tilt like that, like this. They cannot flex this way, which this coupling is not intended to do anyways, but they can still flex like that. What you are supposed to use or to do ideally is, leave these with the gap in the center, and then provide a second bearing that only restrains the rod against going up and down or along the rod, which shouldn't really restrain it that way, because if this guy is bent, then that is going to transfer even more violently into your x-axis. But ideally, in an engineering situation, you wouldn't use bent rods anyway, so it's all a bit of a clutch. So yeah, plastic tubing was Mark 1, that is correct. Well, we don't really have an equivalent for the Mark 2 because the Mark 2 doesn't have any couplers, so. Go tubing, no. Stay cheap. Plastic tub might store some angular momentum. Not exactly. Plastic tubing, no plastic. You announce it, so now use it. Okay. Tubing, add a heat shrink tube. Nah, I don't think the heat shrink does too much. But yeah, so these are super cheap. Divided, I'm not going to do a straw poll. That's going to take the pace out of streaming. So I am going to go with plastic tubing, hoping I can find the right size. It should be like within reach. Let me just go snip a bit here. think I can just use the same one I showed in the video. It is slightly too small, so we will need to heat it up, but that also means that I can just squeeze it over there and get a good fit out of the box. And this will need a bit of help from a zip tie to get it on really tight. The other thing I'd like to know from you guys in chat is can you actually hear me when I walk out of the room? Because yesterday people were complaining that the audio was breaking up as I left the room, and essentially saying, yeah, range was bad, but that is hard for me to believe, as the these road link sets, they are good for like 300 feet. So not sure about that. Good prints. Now, the thing about plastic tubing versus couplers is they can both perform. That there are both absolutely viable options. That neither of them is used perfectly cleanly, as in engineering-wise clean. But I've had my Mendel 90. Mendel 90? Nah, it was the Prusa. The Prusa had the cheapo tube couplers. But my Prusa i2 was built with plastic tube, and it produced some really awesome prints. You'd be surprised that those were from just a really old, really shoddily built machine. Obviously these might slip. These aren't on there as tightly and as firmly as the couplers. So you've got the D shaft on the motor. Let's zoom in on the D. There we go. There is that D cutout on the shaft, and obviously with the tube you get that bit of, it engages with that D shaft, but it doesn't really lock onto it like the grub screw on the coupler does. So yeah, this isn't going to be as tight as the coupler, so this can still slip if like the Z-axis does something stupid or whatever. Do the plastic tubings work with 5,000 RPM? They might. But then again, I probably wouldn't use the cheapo flex couplers at 5,000 RPM. So, how many mods? Nightbot is on raid mode. So, chat is holding up really well. I am impressed. Thanks for the tip, Mindman TV. So I'm gonna go cut these to size in a second. Let's see, these ends should be, yeah, these are okay. These ends are decent. So obviously the length of these isn't gonna be super critical, but I'm just gonna try to get them roughly to length. Because why not? That's one ink. Let's do the same for the other. Okay. Perfect. So, headphone users, be warned. Am I going to use the angle grinder? Probably. But I am going to use the angle grinder or the hacksaw. I will be away for a second. I will be cutting this thing down. Might be a bit noisy. Don't worry about it. I'll scream if I'm, pay today's bloodshed. So is this thing plugged in? Nope. So obviously I cannot see chat right now, but I do have moderators on the job, so be nice while I'm gone. You know what would be hilarious? If I just started screaming in a second and just left the stream running for 2 hours. That would be... that might be something I'd actually do at some point. Right. Hearing protection is on. Safety goggles are on. Headphone users, please excuse this. Everyone else, turn down your loudspeakers. 3, 2, 1, go. Okay, that is one side cut. And that's the other. This is so much quicker than a hacksaw. And I mean, comparing angle grinding stuff with just hacksawing through, it is so much quicker. Especially since the steel used in bolts and threaded rods is decent steel. It's, you know, not the cheapo construction welding grade steel that you use for other stuff. This stuff is much tougher than your angle iron than you usually use. Whoops. So I'm actually going to grind away a bit of the threads out here because I don't want to cut through the holes too much. There we go. This live stream is brought to you by Audible.com. If you want the same audio-visual experience without the visuals, check out Audible.com. Just kidding. I wish they'd sponsor me. I'm enjoying this. Alright, so we got these 2 parts done. So, as you heard me talking about, I did give them a bit of a profile on the end. I think this might be a bit easier on the tubing. Camera! Work with me here. Nope. Okay. I'll just have to move back. So I did grind off a bit of the threading back here. So yeah, this should slide into the tubing more easily and hopefully be a more durable connection. Let's see if I just... do we need some lube for this? Oh yeah. This is going in nicely. Actually, once we get this most of the way in, there's still going to be a bit of a gap. There's still going to be a bit of a gap, but I think if we hold the tubing back here, we can just thread it in all the way. Maybe. Yeah, that actually works. So, yeah, for the most part, I do want to get this one. We can also stretch the tube. Cool. Yeah, cool. There we go. That is, yeah, that's exactly how I wanted it, with the threaded rod seating against the motor shaft, and that is the same concept that I just explained with the flex. Excuse me, with the flex couplers. And this thing is just, you know, backed up against it. You can press on it, and the only thing that's going to happen is we push the motor out of the holder. So that is perfect. Why am I not using a coupler? I am using a coupler. I am using a coupler that might actually work better than the actual flex couplers. And a zip tie. Yes, a zip tie. Where did I put my big zip ties? I'm actually going to grab a big zip tie for this because I wanted... but big ones are not going to conform that well. Let's use small ones. Whatever. The BOM only calls for small zip ties, so I am going to stick to the small ones. Not just one, but two. So let's get this one down a bit further. There we go, there's one. And quick tip, if you have needle nose pliers, you know, grab it and twist it away from the zip tie head. That is going to get it a very tight fit. And then one rotated 180 degrees. Fasten the motor first, maybe. No, I probably shouldn't put this right in the middle between them. What is it slide there? That's where I want it. I want 2 for each shaft. Just, you know, 2 is better than 1. And these zip ties are practically free. These are, I mean, how reliable is a wooden frame? A wooden frame is perfectly reliable, actually. Compared to metal frame, yes, it is going to be a bit bulkier. Obviously, you can see it's much thicker than the original aluminum frame. But I would say it is just as stiff. It's not as pretty, obviously, but yeah, it's gonna work just fine. Maybe you want to rotate the Z-axis motor. Do I? Let's see. So original one has the connectors towards the frame. Can I do this as well? No, I cannot, because this is bumping into all right, you see, that's just bumping into the printed part right there. So that does not work. I could have it facing inwards. I think that's the best idea. Yeah, let's put these with the connector just facing inwards like that. And this part right here, obviously, you can see if we spin the axis right there, that works. That is tightly on there, and I think that's just gonna work beautifully. Isn't OSP more resin than wood? No, it's quite a bit of wood. Particle board, that's probably what you're thinking about. Say the name of the question. People are just writing questions to hear me say their name. Yeah. That's needy. Ooh, Nightbot doing work. Put the head of the zip tie on the flat shaft on the D. Aaron York is saying. Could do that. The shaft is not round. That is correct. This will wobble. Yes, that is also correct. But then again, these, I mean, if you look at this, do you think a bit of wobble is going to matter? Not really. Not really. I've had shafts wobble quite a bit. Quite a bit. And it really didn't matter in the final prints. The only thing is, yes, you need very soft couplers, which we do have, and you need them to be completely unrestrained on the other end. So at that point, it does not particularly matter much whether your shafts are perfectly straight or not. And especially with these thinner ones, that is one of the reasons why I went for M5. First of all, you can use the tube couplers, and second of all, the M5 rods, I mean, these, well, let's do it like this. These do flex a bit on their own too, so they're not like these big ass stiff these big ass stiff M8 rods that can shake your Z-axis around. Why flexible couplers? Because these M5 rods aren't perfectly straight. And why did I not go with T8 lead screw? Because the T8 lead screws are more expensive than M5 threaded rod. And the goal of this build is to build something that gets as close as possible to the Mark II for as cheap as possible. Yes, I realize I could have gone cheaper, but I'm making trade-offs where the trade-offs make sense to me. where they're not going to impair performance too much. And M5 lead screws for ZXs I think are perfectly acceptable. If the Prusa is on the same side as the original, you should make the steppers connectors facing out. Yeah, I just checked on the original one. I think we're going to be fine like this. That is perfectly in focus on the first pull. Awesome. But does the Z-nut fit the carriage? If you check toms3d.org/dolly, you will notice that there are some updated parts, like this one. This is essentially the replacement part for. Okay, it's really tight. It's let me show the individual ones. That's an old one, whatever. But the idea here is that you have these parts on the floor. There we go. That you have these parts that fit the original X ends without any modifications, and you just drop an M5 nut in there, pop them together, and as these get screwed down, the M5 nut locks in place, and you get this perfect compatible replacement part. You want these cutters? Oh, I know you want them. Knipex tools made in Germany. Best pliers you can buy. These were some of my first pliers that I bought, and I am madly in love with them. That's why you see them on pretty much every build stream. Guys, don't cheap out on tools. It's like it's one of the things I've learned not to do. And yes, they cost a bit more upfront, whether it's power tools or like hand tools and stuff, but it's so worth it. It is so worth it. Free giveaway. Yeah. Okay. We got that. Okay, and now we can start mounting these. So expensive. Really, these are like 14, 15 bucks per, per plier. Pliers? Is it plural? Is it like pants? I don't know, pliers. One of these is 15 bucks. Totally okay. Not product placement, just personal opinion. I can do that. I can tell what I like and don't like. Also, this stream is not sponsored by Altersbacher. Drink responsibly. If I'd list all the things that this stream is not sponsored by, it would be half an hour before every stream just going, all these brands are not sponsoring me, but if you want to, you might be able to work something out. Got that. Sweet. Let's see. So let's check what the manual is saying actually. So mount the motors. Use Titan Z motors. Yeah. Got that. So let's do that and then move on to the Z nuts. Yeah. I don't know it. No, I wasn't using the knife as a screwdriver. I was using the knife as a deburring tool. Because this one... Actually, it does fit. Wow. Spamming? Perfect. I'm just saying he really likes his Knipex wire strippers. I have the cheap Knipex wire strippers. They are garbage. That's like the one thing I have to point out. They are... I mean, that they might be fine for the larger wires, but the smaller wires are just barely acceptable. These feel like they are bottoming out, and I don't really want to have that. So yeah, that's something that's really easy to do with these stepper motors, because these don't have a lot of thread in the top aluminum part, which you're essentially screwing into. And if you bottom out the screws, first of all, the motor is not going to be tight. Yeah, I'm just going to put a washer on each of these. But worst case, you might end up pushing out the screws that hold the entire motor body assembly together, because that's the same threading in the top part right there. So just be safe and put a washer on there, and just don't bottom out the screws, or use a shorter screw. But in my case, it's going to be the washer. Would I shave my hair on cam? Depends on what hair you're talking about, what area of my body I should be shaving. Because there's more hair on my body than just on my head. Does the brand of the motor matter? No, that's something I mentioned in the last video I did. Well, as a scripted video, not live stream, I did on the topic. These stepper motors are very generic these days. You can pretty much just buy the cheapest ones and you know, be over with it. Always washers on plastic? Yes, you should. I don't know if the original one has. The original has washers as well, so I guess. Oops, that is cross-threading it. Guess I should be tightening these down all the way yet. How about an upgrade to TMC drivers? Yes, eventually. I am now under the firm belief that every 3D printer should be using TMC drivers after seeing how well, for example, the BCN Sigma does with the TMC drivers, and I've loved on them before. They're just awesome drivers. Someone did print stepper motors yet? Or someone already printed these stepper motors? But obviously, when you need like magnetizable ferromagnetic metals, when printing with plastic instead, it's not the greatest thing to do, or not the most efficient thing to do. There we go. There's one, and let's do the other side as well. I did use the 10 for that. Where to put the washers? There. Yeah, TMC drivers are like, they're not quite the silver bullet that he might make them out to be, but they're really good. They're awesome. Not only do you get a ton of torque from them with basically the same current you'd use with an Allegro or TI driver, but there are, if you do a bit of tweaking, if you choose the right step mode, which most of them come pre-configured pretty well these days, if you do that, you're going to get an absolutely massive upgrade from just swapping out the stepper drivers. Your printer is going to run smoother. It's not going to skip steps as frequently. It's going to be quieter. Your prints are not going to have the steppering. It's really good. Trinamic. Trinamic. German brand. Yes, TMC. That is the name of the stepper drivers themselves. It's TMC 2100 and 2108. So 2108 and 2100. That's the stepper driver names, the actual ICs. They are sold as silent step sticks from Watterott, German brand. And yeah, that's the original one, but I think you can get Trinamic based drivers from pretty much anywhere these days. which mode would I use? I have done a review on the 21001 ones, on the very original ones, and I did end up in what's the in spread cycle? Yeah, not stealth chop. Stealth chop is the super quiet one, but it's very reduced when it comes to the torque you get. And stealth spread cycle is a good compromise. It still does a lot of the trinamic magic with the current modulation and stuff, but you get a lot more torque than in stealth chop. That was my conclusion back then. I don't know how the newer drivers, someone just posted how they were called, TMC 2660 or something. They're obviously larger drivers and a bit more powerful. So yeah, that is something I'll still have to investigate. And I do have a few boards that use the larger ones. I think the Do It Wi-Fi does have the larger ones. Yeah, Do It Wi-Fi uses 2660 as well. Right. Okay, let's move on here. Nuts for the Z-axis. So here's where these parts come in. Titan trapezoid motor nuts. So we are going to not use the M3x12. We're actually going to use some that are slightly longer, because the parts that we're using are slightly longer. And I think I also eliminated the M3x12 from the BOM that I posted. So M3x18 is going to be 10, 30, 18. These baggies are great, like I mentioned, but as soon as they break on a corner, you're screwed. You're completely screwed, because stuff is going to go everywhere. Do I finish the build today or in another stream? I will finish another day. I was trying to make a pun of that, but I don't think that was working out. We're not going to finish the build today. Actually, I don't think I'm going to build too much longer today. I'll try to get the x-axis on there. But this should be just like little tiny bits of streams and videos. These longer, I don't know, 15-hour streams, they are wearing me out pretty well. So tiny bits like this, and one stream at a time. Yeah, so I did, if you look at the parts from tom3d.org/Dolly, these nut holders, there were a few different ones. These are the ones that you can download right now. These are super tight. They have these 6 holes around the edge, and at least for my printer, these fit the nut extremely well. So yeah, if you're building this, definitely get the newest version of these files. It will make a difference. Right, so let's move the frame out of the way and get back onto the x-axis. I don't know why we didn't install this one before. Would it be nice to just do it in one go? Did I order M3 nuts? I don't think I did, because I have plenty of them. Metric fastener assortment. So nice. So nice. When will it come back? Tomorrow? Probably same time, same place. Need a quiet printer soon? Well, then look into the trinamic drivers. Come on. Come on. So there is a tip in the build notes for the Mark II, as in how to insert your nuts properly. So, in case you don't manage to get your nuts in in the whole thread, and that is just to take a bolt like that, thread it on a bit, and then push it in. And that's going to be important for, I think, especially the extruder parts. Come on. Well, this one is just too tight. It feels that way. Well, we've got it. The other trick I would like to present is just taking a screw, putting it through, and this one is okay. We need to drill this thing out. And essentially pre-tightening the nut into the hole from the other side first. Right there. So again, this is a bit of a bad combination. These are stainless steel screws onto galvanized nuts, and the galvanized layer on these, if they ever get in contact with water, they are going to wear down really quickly. So ideally, you do want to combine stainless nuts with stainless screws and washers and everything. So yeah, if you don't have stainless hardware all the way through, or galvanized hardware all the way through, which is totally fine as well, you know, pure galvanized hardware is much more resistant to everything than most people make it out to be. Yeah, if you can't match them up for this printer build, it's probably not going to matter too much, but you still should try, just for good engineering's sake. Yes, all these parts are ABS. You could use PETG, but PLA is out of the question, because PLA is not great for long-term durable parts, and anything that gets warm is going to warp. Why did all the old the old Mendel designs use anti-backlash nuts on the Z-axis? That is a good question. I actually don't know. I can't really answer that. I have built a Cells Mendel. I've built a a Prusa Mendel, and then the i2 version of that. They've all had like a spring-loaded double nut in the... That was actually sliding in pretty nicely. They all had a spring-loaded double nut on the... Am I using a... Hold on. 2 and 3 nuts. They all had a spring-loaded Z-axis. So as you had the threaded rod through the ends here, they had one nut up top that was like the load-bearing one, and then another one. There was, well, the other way around. Another one that was essentially pushing the Z-axis down and tightening it against that load-bearing nut. So that was done to like curb, a fear of backlash on the Z-axis. The thing is, the Z-axis is pre-tensioned by gravity anyways, so it's not a huge issue. Either way, if you want to put like anti-backlash parts on it, go ahead. But I don't think you really need it. It was more of a measure against something that could potentially maybe happen at some point, but for the most part, it's gonna be fine. Right. There's my nuts in their cases. And these just drop in on the tops like this. Yep. Just like that. And then we got these screw. I'm hoping these are large enough. Yes, they are. Let's go right in here. Obviously, I did drill this out with a 3mm bit. That's going to make for a somewhat okay-ish, tight-ish fit. Let's okay. I will have to loosen this one up a bit in a second. Oh, or maybe not. I'm actually okay here. I know I should be using washers here. But then again, yeah, whatever. Gonna be fun. What's a good cover for the Mark II? The thing is, the Mark II is not a printer that's like easily encased. I assume you are talking about an enclosed chamber for ABS printing. I put it in a plywood OSB box. Not the most elegant solution ever, but it sort of works. It's probably going to be a custom solution if you want to encase a Prusa style machine. Put that in. Okay. By the way, one question for everyone watching. Today I uploaded some new channel graphics sort of thing. It's not a huge update, it's just a little tiny, improvement, and that's gonna, it's gonna improve more along that same direction in the future. But what do you think about if you go to my channel page and ideally hit that subscribe button, and click my face in the video description. Check out the graphics on the top of that page. What do you think about that look? I am thinking about extending it to more parts of the channel. Your feedback is appreciated. There you go. Okay, so these are compressed. Nice bokeh, that's always been there. That's been one of the first things I did on channel design. Right, so we've got the nuts on there. This is nicely compressed. This embedded nut in here is not going to move at all. This one is also not going to move anywhere. Update the profile pic. Yeah. Yeah, the low poly look, that's something I eventually do want to make like t-shirts and stuff, and I was thinking like with a frog on there and just have like a low poly breakaway in it. Could look pretty cool. You should use Blender to do new graphics. I actually did that thing in Blender. That is the diamond-like structure you see on the actual diamond shape. That is actually rendered out in Blender. I know Blender, yay! Yeah. Looks a bit weird. Okay. Right, let's see. We've got nuts orientation does not matter. Well, it doesn't matter when you're building a 3D printer. Got it. Shortest rods. Insert in the bottom parts and then slide on the x-axis. Cool. Until both trapezoid screws are exposed. So we're going to screw this onto the frame essentially. I should switch the font. I already switched the font. I switched from Roboto to Lato, both Google fonts, and I am liking the new look a lot better. Let's see. So this guy goes in like that. I'm gonna have to prop this one up a bit. So screw packets. It is. You should use 3D printed low poly LED illuminated wall pieces for the sets. Maybe, yeah. Diamond is too offensive. How is a diamond shape offensive? Please elaborate. As in aggressive? Because I don't think I'm offending any political or religious group with that logo. Well, at least I'm hoping I'm not. Ubuntu font is the best font. Well, there really is no best font. If you ask most people on the internet, they're going to tell you Comic Sans is the best font ever. But obviously, that I would disagree with that. Someone's saying, Frederick is saying he thought I was going to use ASA. I've actually got the Mendel 90 conversion build pretty much all done in ASA, so I'm getting a good bit of use out of that. Yeah, it's okay. Well, thanks for the compliment. It's okay. It's decent. By the way, thanks for the tip, guys. Abium 5 years. How about likes? Yes, how about those likes? Also through stream tip, which one did I miss? John Miles, 2 times 2 years. Thank you for that. Andreas, 3 years and 3 years 50 from, and the page refreshed. Icicle, Trepan, your live streams are great. Yay! I'm doing something right. Right. Yeah, thanks for that, obviously. So, I'm gonna have horrible Z-wobble. No, I'm not. Watch and learn. So, that's on there. Carefully inserted, place the Z-axis top parts. Yeah. Check both lead screws in the upper part. They shouldn't touch the edges. Well, these are definitely not going to touch the edges. So right now the motor is obviously a bit lower than the frame, so I do have these propped up on some boxes. Yep, wrong side. This is gonna go in here. Oh, that's tight. That is still like really tight. Do you know of any Egus compatible Prusa clones? Depends on which Egus bearings you're looking into. There are Egus bearings that are, compatible as an LM80U drop-in for everything. So, yeah, let's just use cordless drill. What am I doing? So, yeah, those are obviously compatible with pretty much every 3D printer. Ooh, shouldn't bend that much. But no, I don't know any specific i3 versions that are specifically made for Egus bushings. Maybe Czech can help you out there. Okay, so this one is a bit too long, as I'm just noticing. So let's unscrew these screws a bit and tighten it a bit more. Just pull the x-axis down, the screws will rotate on their own. Well, we're not building an original i3, we are building a clone, and we are using different lead screws there. Oh, I am Hulk! I am not Hulk. I'm just realizing. Okay, so these are... Well, let's see. Ideally, these should fit in a bit further. Don't want to bend anything, so what do I do? I guess the easiest... So the problem I'm facing right here is that these smooth rods are being pressed to the outside by the length of this x-axis. So no ambulance today. So what we're seeing is that the Z end here, maybe I can rotate this into the camera over here. The Z axis over here, yeah, you can see that in the background. This is with these screw holes lining up. As you can see back here, the smooth rod and the hole it's supposed to go into does not line up, and that means right now the smooth rods are actually tilted away from each other. So maybe hammer time. One thing to check first is the length of these, or the distance of the smooth rods. So this is 35.7 centimeters, and this is 35.8. Well, that's closer than I was expecting it to be. But still, it means that this part will need to go, or will need to be a bit more compressed. Let's try the hammer method real quick. And because we have the motor connected on this side, this thing is going to have some inertia, and we're actually just hammering this together, hopefully. Nope, we are not. Let's check again. Okay, this is not coming along. That's a great thing with these. These are like 3 meters drop rated, so onto concrete. So it doesn't hurt the drill. I've done that plenty of times and it's still working fine. Let's try something else. Let's try one of these, and I'm hoping that's the good one. Nope, that's the broken one. Yeah, that's the good one. Also, this stream is not sponsored by Wolfcraft. Wolfcraft. Yeah. Right. That should, if anything, this should compress it together. Prusa does not include a hammer. No, he does not. This thing is not... What? Why is this... So something is bottoming it out. I think I did cut the smooth rods to the correct length, I believe. Audio cuts out? Okay. I'm not moving that fast, guys. Parts are broken. Are we gonna have the same stream tomorrow? Nah. I think I would just soundly rebuild it in shame. Rods too long? I do not think they are. What am I doing? I'm trying. So, what I'm thinking the issue is that one of these parts is a bit too tight on the end for these smooth rods, because the drill only reams this far. But it is looking like that is not the case. It's actually looking like the rods are a bit too long. I did cut these to the exact length of 370 millimeters. Or have I? No, I have. But it looks like these are not fitting. But I'm guessing this is as good of a point to call it a day as any. So yeah, again, this stuff does not line up currently, and I will need to take the entire x-axis off, and there's no PLA dust in here. I will need to take the entire x-axis off, shorten the rods a bit, or drill out the x-ends a bit more, but I don't think that's going to be very enjoyable to watch. So yeah. Do I happen to have any news about the E3D Titan? I don't know, maybe if you look at yesterday's stream. But yeah, these are too long, so I will take this apart tomorrow. It is 10:20 p.m. So bolts on the end, I took those out. Don't worry about that. Yeah, I'm going to do that tomorrow. We're going to have another stream tomorrow in which we will finish up the Z-axis. But so far, I mean, I'm liking how this is coming together. So let's switch back here. The Z-axis couplers, the tube couplers actually do work pretty well. Of course, if you look at that, this ooh, that's quite wobbly, but I actually don't think it's going to matter too much for print quality. I don't think it's going to matter too much because these are thin rods and we have these super soft couplers down here. Yeah, we got that assembled. We got the X-axis assembled. Y-axis obviously is already finished up. So yeah, it's coming along. It's coming along. We are getting there. Any questions left? Smooth rods from a 2D printer? No, probably not, because first of all, those are going to be the wrong length, and also there are often going to be weird sizes. I did make a video of making a sacrifice something. That's an older one as well, and I found like the weirdest sizes. So probably not. Yeah, probably not the best source for smooth rods. Yeah, when the tube perishes, that's going to be a while. It's going to be, you know, when this thing wears down, the rest of the printer will have worn down too. So I don't think these are too much of an issue. Again, these look pretty good. Actually, this is already pretty solid. But yeah, these do look decent. Obviously, the Z-axis wobbles a bit, but the Z rods wobble a bit, but that's fine. That's totally fine. Adjusting the bolts on the right. The problem is, I would need to adjust both the top and the bottom parts, because if I adjust one side, we're just going to tilt them even more. Remount the holes. That is an option I could also look into. You know, opening up the holes in the frame, because like I said, these are just being tapped into right now. These are being screwed into, but they the option I have is, you know, drilling them out with a 3.5 or 4 millimeter drill and just screwing through, putting a nut on the back, and we would have a perfectly adjustable X-axis. Maybe that's what we're going to do tomorrow. I'm going to look into this tomorrow morning and check it out. What else? TMCs. Yeah, that is a that is a topic for another video. Right. Oh, that is smooth rods with the bushings from the same printer. So one good question, or one good thing that's coming up is, well, coming up, but I sort of want to touch on is printed bushings. We are obviously using MK2 bearings. These are ball bearings, as you can see when you look into the bearings themselves. There are little balls in here, rows of them, and obviously focus hard, camera coordination. You can sort of make out the rows of balls in there. There's one glistening at the bottom there, and these are ball bearings. These need proper chromed and hardened rods, or just hardened. Hardened works as well, but the chromed ones don't rust, which is a good upside. You can go with Egus bushings. That's something that's been suggested. Egus bushings are like the professional solution. Egus bushings and just plain steel or stainless steel bars instead of the hardened ones, because these are like $26 for the full set. And then of course you'd pay a bit more for the Egus bushings, but maybe end up with a lower price overall. Could work. That is an option. We're going to look into that after this build, obviously. Or you could print LM8U compatible bushings from PLA. That sort of works. It's been done again in that Prusa Mendel area. It's been very popular there, and supposedly it works pretty well. It's going to have some of the same issues as the Egus bearings if you don't, you know, make them super tight and don't pre-tension them. They might be a bit springy. I've not tried them too much, but they are definitely an option of, you know, reducing cost. Right, printing bushings with filament. yeah, not too much yet. I've tried it. It can work. It does need a lot of lube, but yeah, can work. Pinto pizza. Nope. All right. One more question on bushings from Julius is why I'm not using sintered brass bushings or something along those lines. And the problem with the brass bushings is, first of all, how do you mount them? There are some self-aligning eyelet type bushings. You can use those, but the bigger problem I'm having with like brass bushings onto shafts and like the DIY setup is, first of all, if you don't align them really well, they are incredibly finicky to use. They will grab onto your rod if they're just slightly misaligned, or you know, if you align them perfectly, you are going to have to use them with such a low tolerance that you know, it's a very tight match between the bushing and the smooth rod. So yeah, it's a bit too tricky. I do prefer the Egus ones instead. But yeah, I guess that is a good time to end it today. Thanks for watching. We will see you tomorrow again, probably 8 p.m. my local CET time again. Yeah, again, I'm going to look into this tomorrow. For now, it is, yeah, 10:30 p.m. Pretty good. Good night, everyone. Thanks for watching. Get subscribed, Patreon, check it out for one-on-one hangouts and, you know, more private Q&A sessions. Get subscribed. Did I already mention that? Hit the like button on the video because live streams are, if you made it this long, I would appreciate that. Live streams always get a bunch of thumbs down because they are a different format. But yeah, do that. Click that button if you enjoyed it. If not, obviously click that other one. But yeah, good night. Thanks for being here, and I will see you tomorrow. Definitely live again. Good night, or good morning, or whatever time zone you guys are in.